Imagine you're a detective solving mysteries about how big things grow or how fast things shrink. Your secret tool? The math superpower that turns complexity into simplicity? Logarithms. Now here's the magic. Logarithms answer the question, what's the power behind the number? For example, if 2 raised to 3 is equal to 8, then log 8 with a base of 2 is equal to 3. It's like asking, how many times do I need to multiply 2 to get 8? Alright, now that we understand the magic of logarithms, welcome to the logarithm party. Here, every log property has a role to play, turning math problems into pure magic, so let's meet the key players.
First up, we have the additive wizard, the product rule, which is equal to the sum of the logarithms of its factors. Introducing the product rule formula. Log of x times y with base b is equal to log of x base b plus log of y base b. This rule tells us that when we multiply numbers inside a log, it transforms into addition outside. For example, log of 8 times 4 with base 2 is equal to log of 8 base 2 plus log of 4 base 2. Another example, log of x base 4 plus log of 32 base 4. Using the formula, it will become log of x times 32 with base 4. Multiplying the numbers inside the parentheses, it will become log of 32x with base 4. Translation, multiplication becomes a quick and easy sum. Next, meet the subtraction ninja, the quotient rule, which is equal to the logarithm of the numerator minus the logarithm of the denominator. Introducing the quotient rule formula. Log of x over y with base b is equal to log of x base b minus log of y base b. Logs don't like fractions. They settle division problems by turning them into subtraction. For example, log of 27 over 9 with base 3 is equal to log of 27 with base 3 minus log of 9 base 3. Another example. Simplify log of 6 with base 2 minus log of 4 with base 2 as a single logarithm. Using the quotient rule formula, log of 6 base 2 minus log of 4 with base 2 is equal to log of 6 over 4 base 2. Both 6 and 4 have a common factor of 2, so log of 6 over 4 with base 2 is equal to log of 3 over 2 base 2. And just like that, complex fractions vanish. Lastly, meet the power lifter, the power rule. The power rule states that the log of a power x raised to n is equal to the product of the exponent n and the logarithm of the base x. Introducing the product rule formula. Log of x raised to n with base b is equal to n times log of x with base b. Logarithms are pros at handling exponents. When you see an exponent inside the logarithm, the power rule brings it down to a simpler form. For example, log of 8 raised to 3 with base 2 is equal to 3 times log of 8 base 2. Another example, simplify log of 81 raised to 2 with base 3 as a single logarithm. Using the power rule formula, log of 81 raised to 2 with base 3 is equal to 2 times log of 81 base 3. Now we know that 81 can be written as a power of 3. So 81 will become 3 raised to 4. Why? Because 3 times 3 times 3 times 3 is equal to 81. Now, using the property 2, which is log of b raised to x with base b is equal to x, 2 times log of 3 raised to 4 with base 3 will become 2 times 4. Multiplying these two will get 8. So big powers, logarithms make them manageable.
Now, let's try to answer a real-world example. The problem: too loud at the concert? Cherish and her friend Divine are at a rock concert. The music is loud, and Cherish was wondering how much louder is the rock concert compared to a quiet conversation. Our situation: a quiet conversation has an intensity of 10 raised to negative 9 watts per meter squared and a decibel of about 30, while the music at the concert has an intensity of 10 raised to negative 3 watts per meter squared, and it has a decibel level of about 90 decibels. How much louder is the concert than the conversation? Now, we know that the sound intensity is measured in watts per meter squared, and the decibel scale uses a logarithmic formula. D is equal to 10 log quantity I over 10 raised to negative 12. So our first step is to find the decibel levels for both sounds. For the conversation, L1 is equal to 10 times log quantity 10 raised to negative 9 over 10 raised to negative 12 is equal to 10 times log quantity 10 to the power of 3 is equal to 10 times 3 equal to 30 decibels. While the concert is L2 is equal to 10 times log quantity 10 raised to negative 3 over 10 raised to negative 12, and it is equal to 10 times log quantity 10 raised to 9 equal to 10 times 9, and then finally it equates to 90 decibels. Now, the second step is to equate the difference in decibel levels. L2 minus L1 is equal to 90 decibels minus 30 decibels is equal to 60 decibels. Now here is the interpretation using the logarithmic quotient rule. A difference of 60 decibels means the concert sound intensity is I2 over I1 is equal to 10 raised to L2 minus L1 over 10. That equates to 10 raised to 60 over 10. Then finally coming up to the answer, 10 raised to 6. Now, the concert is 1,000,000 times more intense than a conversation. This tells us that without the quotient rule, calculating this ratio directly would be difficult. Now that's it for this video, and we hope you learned something.